Welcome in Cool. As we learn new things about something, we start to believe we know a lot about it. But this isn't often the case with space. Our solar system is much, much bigger than you would expect, and you'd be surprised how little we know about it. But soon, with the launch of a next-generation telescope, that might change. Does this mean we would finally detect an elusive Planet 9? Will we find some other secrets our solar system has stored for us? And would it all change the way we perceive our place in the cosmos? Now, get ready to discover answers to this and more. INTIO, the search for Planet X, referred to as Planet 9, but sometimes referred to as Planet X before Pluto's reclassification. This is an elusive world orbiting far beyond Neptune. It's been a mystery for scientists for decades. Since the beginning of the 20th century, astronomers suspected the existence of a large body affecting Uranus and Neptune. But once Voyager 2 approached Neptune in 1989 and sent us back data, it became clear we had wrong calculations. It turned out there was nothing weird about the two gas giants. It looked as though the hunt for Planet X came up empty. But that wasn't the end. Just recently, one curious scientist decided to look through the 38-year-old data from the infrared astronomical satellite IRAS, the very first telescope that managed to scan about 96% of the night sky. And among about 250,000 point sources, there were three specifically interesting ones. But how do you look for something in our solar system? If you take a telescope and look in a specific direction of the night sky, you'll see a bunch of dots. Some of those are distant stars, and some are solar system objects. So how do you distinguish one from the other? You look at an object's motion. If it barely moves or doesn't move whatsoever, the chances are it's located quite far. But if an object travels a significant distance in space within a relatively short period of time, it means it's close enough in our solar system. Only 1 out of 3 objects from the IRAS data that met astronomers' requirements was captured moving through space. This is when the scientific community became thrilled. If the IRAS data is right, a planet we've been looking for should be 3 to 5 times as massive as Earth and orbit at a distance of approximately 225 astronomical units, 1 AU being the distance from Earth to the Sun, which is 149,597,870.7 kilometers, 92,955,807.3 miles. But the other 2 scientists involved in the search didn't agree with that conclusion. However, they found yet another theory of Planet 9's existence. And, once again, the search got a new course. On the outskirts of our solar system lie 6 space bodies called Extreme Trans-Neptunian Objects, ETNOs. And they aren't just some random objects. They all have one thing in common that makes scientists curious. All 6 of them have an orbit pointing in one direction. And because the chances of such distant space bodies with such an alignment are roughly 0.007%, we know there's something causing it. A gravitational influence of a much larger body somewhere out there. All the strange phenomena could be explained by a planet 2 to 4 times the radius of the Earth and almost as massive as Neptune. It would also have a highly eccentric orbit, getting close to our Sun at about 200 Australian dollars and then moving away at a mind-blowing 1,200 Australian dollars. Such an elongated orbit would have a 20,000-year orbital period. The only thing scientists lacked to make their theory look promising was several objects with even stranger elongated orbits. But as it turns out, another astronomer has just discovered such objects exactly where this theory would predict them to be. Still, knowing Planet 9's orbit doesn't tell you where on its orbit it currently is. Nevertheless, there are things that scientists know for sure, and by means of pure logic and mathematics, they can make predictions on where to look for it. For example, at its nearest point to the Sun, Planet 9 has a brightness of 18th magnitude. So if it recently was that close to us on its orbit, it would have been easily spotted. And because of that, we think it's closer to its furthest point where it is as faint as 25th magnitude, which makes it harder to notice. How bright is that? The smaller the number, the brighter the object. To compare, Pluto's average magnitude is approximately 15. Thankfully, 25th magnitude is still in the range of what the Hubble Space Telescope is able to detect. This is 10 billion times fainter than the human eyes can see. Where is Planet X, so while we don't know for sure where it is, we have decent proof to think it's there. You may think it's impossible to find such a distant object given the data we have, but we have already found a planet based on our predictions once, Neptune. Astronomers of the past believed something was tugging Uranus, but they couldn't find any reasonable explanation. Later, one scientist, using classical celestial mechanics, made a prediction on the location of a hypothetical planet that was supposed to be in charge of what was happening to Uranus. Using those calculations, astronomers were able to locate Neptune exactly where it was predicted to be in just one night. But while Neptune orbits our Sun at about 30 astronomical units, Planet 9 is expected to be much further away. Because of the great distances and how dim Planet 9 is, our chances aren't that high. But that could change very soon. A new generation of telescopes are on their way, and one of them, Vera Rubin Telescope, is currently being built in Chile. Scheduled to begin operations in the fall of 2023, this is going to be an 8.4-meter, 27.5 feet telescope with a 3,200 megapixel camera on board. The camera, the size of a car, is going to be the largest camera constructed for astronomical purposes. With such a tool, scientists could not only verify if Planet 9 actually exists, but also find roughly 20 terabytes worth of space objects and other phenomena in one night. Just in a year, the observatory will be able to capture more of the cosmos than all the telescopes on the Earth ever did combined. This can turn our perception of the universe and our place in it upside down. If you'd like to see a full video about this telescope and what it could find, make sure to let us know. But what if we scan every point of the sky where Planet 9 could be and find nothing? Well, there's an idea that Planet 9 could be mistaken for a primordial black hole that would cause similar gravitational effects. Although it's purely hypothetical, as we haven't detected one yet, at the very dawn of the universe, when everything was much denser and hotter, primordial black holes popped in and out of existence within just a second. And depending on when during that second such a black hole was born, its mass could have been as little as 5 to 10 grams, 0.17 to 0.35 ounces, or as enormous 100,000 solar masses. The thing is, if our calculations about an elusive planet's mass are correct, a primordial black hole a few times the mass of Earth would only be the size of a grapefruit or even smaller than a human fist. And if that's the case, we have no chance of finding it with a telescope. Ever. Although, we may just detect it with a more aggressive method. The idea is to send hundreds or even thousands of small laser-propelled spacecraft and test the gravitational field of a possible primordial black hole. Even if just a few of these tiny spacecraft pass a black hole at a distance of tens of astronomical units and send us back data, it would be enough. But how would we know if we were right? We could figure out if a black hole is really out there by measuring intervals between those signals. If it's there, the signals will lengthen under the gravitational influence of this mysterious object. Yes, Planet 9 has lots of theories surrounding it, and even that isn't the last one. Rogue planets, after all. Planet 9 could have once been a rogue planet, or such that was freely wandering through space without any stable orbit. And sometime in the past, it could have been captured by our star's gravity. That may seem unintuitive to you, but some studies show that, in our galaxy, there are more planets unattached to a star than those orbiting one. What's interesting is that, according to simulations, in 60% of cases, rogue planets just enter the solar system and leave it, but in 1 out of 10 cases, such a planet could take another planet with it on its way out. But there's also a 40% chance that a rogue planet won't be able to escape a solar system once it enters it. That is one possibility of what Planet 9 could be. Besides, we have already discovered some rogue planets in the past. Looking for such worlds is no easy task. A rogue planet, a star behind it, and an observer should be aligned almost perfectly. And the only way we know it's there is if its gravity bends the light emitted by a star behind it when a planet flies past it. 2 such events with perplexing names became promising rogue planet candidates. One of them is suggested to have a mass range between Neptune and Earth, while the other one could be as massive as Jupiter or even as a brown dwarf. Not so long ago, the Kepler Space Telescope possibly detected 4 new Earth-sized rogue planets wandering through our Milky Way. So far, we don't know much about rogue planets, but what's interesting is that some scientists think they can actually be habitable. But how could a planet that doesn't get enough light sustain life? Well, there are 3 possible scenarios: subsurface oceans, tidal heat, and an active galactic core. The odds for life on the surface of such space objects are close to 0. That's true. Subsurface oceans, on the other hand, could not only host microbes but something bigger as well. A rogue planet's interior or its highly dense hydrogen atmosphere would trap some heat and prevent these oceans from freezing. Even within our solar system lies a frozen object that has liquid water on it, Europa, pronounced as your times rho times PUH, Jupiter's moon. A massive moon surrounding such a planet could also cause tidal heating. Under the right circumstances, if a smaller celestial body orbits a much larger one at a close distance, the gravitational pull of the larger body would distort the shape of a smaller one, and, similar to the way a piece of wire heats when you bend it, it would heat that object. A rogue planet traveling through space near an active galactic nucleus would also be able to get enough light from the center of a galaxy. And as long as a rogue planet stays within 1,000 light-years from the galactic core, it could even sustain photosynthesis. Our solar system is a strange place with its 4 giant worlds and 4 smaller planets. To scientists, this looks odd, as if something was missing. And what are the chances that astronomers working centuries apart repeatedly come to the exact same conclusion? There is something there. Well, far out. The most distant object ever found by a human being in our solar system is just some 130 Australian dollars away. Add another 1,000 Australian dollars to that number, and you arrive at the farthest point of Planet 9's orbit. So, there's still a long way till we master our searching abilities, but hopefully, Vera Rubin Observatory will be a huge step toward finding out more about the mysterious place we live in. Thanks for watching Dark Core, and stay tuned for more exciting things about our universe.